All right, our final topic for the day is finding inverse functions of exponential functions or log functions. We have found inverses before. We spent an entire day on it in 6.6 where we switched our x and our y in our function and then we resolved for our new y. This is the same thing, just using logs and exponent as our functions. F of x is equal to 6 raised to the x power. So our first step was to rewrite from function notation to just a y equals notation. So y is equal to 6x. And then the next step is to switch the x and y location. So I'm going to put x over here, I'm going to put y as an exponent, and fill everything else in. So I have x equals 6 to the y power. I need to solve for y, but it's stuck in an exponent. But I learned a skill today, rewriting into log form, that will allow me to get y on one side by itself. So let's take a look. However, before we go to swirling, here's something we need to notice. Remember that our x was on the right before. So I actually, before I do anything else, want to rewrite this, flipping the sides around so that my swirling actually works properly. 6 to the y is equal to x. And now I can swirl. 6 to the x and then y. So we will have log base 6 of x is equal to y. Okay, now I have my function solved for my new y. And I can rewrite that in function notation. Remember that we use a -1 as an exponent to say f inverse. So f inverse of x is equal to log base 6 of x. Let's try another one. And this one has the exponent with a base of e. We're going to approach it the same way. We'll rewrite our equation as a y is equal to e raised to the x plus 2 power, and then switch the places for x and y. So I'm going to put an x here, a y here, and fill everything else in. So equals e to the y plus 2 power. All right, how do I undo an e? Well, with a natural log that has a base of e. So I want to natural log both sides. I know that sounds a little weird, but that's what we're doing. So I'm going to say natural log of x is equal to natural log of e raised to the y plus 2 power. Now the whole reason we did this, remember our properties from before, a natural log and an e will cancel each other out because they are opposites, they are inverses of each other. So this is going to allow me to rewrite as natural log of x is equal to y plus 2. Well, we're almost there. I just need to move the 2 to the other side to get y by itself. So I'll do that by subtracting. Natural log of x minus 2 equals y. And then finally rewrite this in function notation. F inverse, remember it's a -1 to indicate inverse, of x is equal to natural log of x and then minus 2. Now we're going to try a couple where we are starting with a log function. We're expecting our inverse to end up as an exponential function. So let's try the first one. Same as before, y is equal to log base 2 of x plus 5, and then swap out the x and the y. So we'll have x here, we'll have y over here, and I'm going to fill in the rest. Equals log base 2 y plus 5 in parentheses. Okay, I want to get rid of a log base 2. The inverse of a log base 2 is an exponent with a base of 2. So I'm basically going to create a base of 2 and make each side the exponent for that base. So I'm going to say 2 raised to the x power is equal to 2 raised to the log base 2 of y plus 5. Now I know that looks super weird, but it works. Remember that exponents and logs cancel each other. So 2 and log 2, because this is a base of 2 on an exponent and this is a log base 2, those cancel. And so I am left with everything else. 2 to the x power is equal to y plus 5. I want to move the 5 over so that I have y by itself. So 2x minus 5 is equal to y. And now I have y solved for. I can rewrite in my function notation f inverse of x is equal to 2 raised to the x power minus 5. I'd like for you to pause the video and try this very last one, remembering that in order to get rid of a natural log, you need an exponent with a base of natural base. All right, let's see how you did. First step, change f of x to y. Second step, swap x and y. I need to get rid of a natural log. I can't do anything with the stuff in parentheses until the natural log is gone. And to get rid of a natural log, I need an exponent with a base of e. So I'm going to make this an exponent with a base of e, and this whole thing an exponent with a base of e. So I have e to the x is equal to e raised to the natural log of y plus 3. E and natural log cancel each other. We are left with e to the x is equal to y plus 3. Move the 3 over. E to the x minus 3 is equal to y. Finally, just write in our function notation, f inverse of x, remember this -1 means inverse, is equal to e to the x minus 3.